Imagine you're managing a global, mission-critical SAP database landscape.
Right, which is already a high-stress scenario on a good day.
Exactly. And suddenly, a massive security patch drops for the database binary.
Oh, man.
If we rewind the clock even just a few years, you already know exactly what that meant. You are looking at a grueling weekend downtime window.
Yeah, you're coordinating with offshore teams, communicating outages to some very angry stakeholders.
You're downloading these massive SAR files from the SAP support portal, unpacking them, and manually running the SAP Database Lifecycle Manager.
Just hoping, really praying that the hardware doesn't throw a kernel panic halfway through the upgrade.
Right. It was just a nightmare of manual execution.
But today you schedule a simple stop and start sequence. You literally go to sleep, and while you're sleeping, a Kubernetes control plane silently spins down the container running that old binary. It spins up a new pod with the patched database, reattaches your persistent storage volumes, and brings the entire system back online in minutes. I mean, it is a completely different world.
Welcome to the deep dive. Our mission today is to provide you with an intensive, technically dense study guide for navigating this new world, specifically the SAP course on provisioning and administering databases in SAP HANA Cloud.
We are tearing down those old on-premise paradigms today.
Rebuilding your understanding from the ground up for the multi-cloud era. Now, I'm going to be looking at this through the lens of an enterprise architect. My obsession is the structural logic of the SAP Business Technology Platform, or BTP.
The high-level strategy.
Right. I want to understand the strategic dependencies, the overarching governance frameworks, and how we design resilience when we don't even own the underlying hardware anymore.
Yeah, and you can design the most elegant multi-cloud architecture on a whiteboard. But as the lead basis engineer, the person who actually has to keep the lights on, I am looking at the exact execution mechanics.
We have to translate that strategy into reality.
Exactly. So I am going to walk you through the precise configuration paths, the strict system limits you're going to slam into, how to troubleshoot execution failures, and the exact command line interface syntax you need.
Because we aren't doing surface level theory today.
No, we are getting into the exact commands, the parameters, and how to operate SAP HA Cloud at a massive automated enterprise scale.
Perfect. So let's start by framing the fundamental architectural shift that you have to internalize before you even touch a keyboard.
The multi-environment foundation.
Right. We are operating in the SAP BTP multi-environment foundation. And the core concept here is the shared responsibility model. SAP HHA is a managed database as a service, or DBaaS.
And it utilizes an in-memory first hybrid transactional and analytical processing architecture.
HTP. Let's pause on HT for a second because it dictates the underlying hardware behavior, right?
It absolutely does.
In the old days, you had an OLTP system online transaction processing, like SAP ERP for your day-to-day writes.
Fast row-based inserts.
Exactly. And you had an entirely separate OLAP system online analytical processing, like SAP BW for your heavy reads.
Columnar aggregations.
Right. And you had to physically move data between them via ETL jobs overnight.
Which basically meant your analytics were always, at least 24 hours out of date? And you were paying for double the storage.
Precisely. The HTAP architecture of AERNA merges them. You execute real-time transactions and massive analytical aggregations against the exact same in-memory dataset simultaneously.
It's incredibly powerful, but it requires astronomical compute resources.
Right, and here's where the architecture gets interesting. This SAP multi-cloud foundation is deployed directly on top of hyperscalers. We're talking AWS, Google Cloud Platform, Microsoft Azure, Alibaba Cloud.
But BTP completely abstracts that underlying infrastructure as a service layer away from you.
And that abstraction, that is the biggest shock to the system for a traditional basis administrator, isn't it?
Oh, absolutely. You are no longer managing storage LUNs on a SAN array. You aren't configuring network interface cards or, tweaking Linux kernel parameters in SUC or Red Hat.
To use an analogy, it's sort of like moving from building your own restaurant from scratch to leasing a fully equipped, high-end commercial kitchen.
Right.
In the old on-premise model, you had to pour the concrete, run the plumbing, wire the electricity yourself. If a pipe burst, you fixed it.
A hardware failure was your problem.
Exactly. In the SAP BTP DBaaS model, SAP is the property manager. They guarantee the plumbing works, the electricity flows, the stoves are state-of-the-art.
So your job isn't fixing pipes anymore.
Right. Your job is orchestrating the chefs, designing the menu, making sure the kitchen can handle a Friday night dinner rush. You're orchestrating the workload.
Which brings up the execution reality. Because SAP manages that underlying hardware, the operating system, and even the database binary patching, Our daily operational focus radically shifts.
Where does it shift to?
It shifts entirely to provisioning compute capacity, managing catalog content, and enforcing user security models.
Okay, but to understand how we execute those tasks, you really have to understand exactly how SAP is running this infrastructure behind the curtain.
Right, because SAP HANA Cloud instances do not run on bare metal servers. They run inside a massive SAP-managed Kubernetes container cluster.
And this containerized approach is the absolute bedrock of the SAP BTP multi-environment strategy. As an architect, when I design a modern system, I am deploying applications or database extensions across 3 distinct pillars in this BTP environment.
You have to know these pillars.
First, there's the Cloud Foundry environment. This is where you deploy your polyglot applications.
Meaning apps written in Java, Node.js, Python.
Exactly, using open source platform as a service standards. Second, you have the Kaima environment, which is SAP's fully managed Kubernetes runtime.
This is where you extend SAP solutions with event-driven serverless functions, containerized microservices.
Right. And third, the ABAPI environment, which is highly optimized for cloud-native ABAPI development. But look, if we step back, this raises a major structural question for your team.
The existential basis question.
Yeah. If SAP manages the underlying hyperscaler hardware, the Linux OS, the Kubernetes container orchestration, and they handle the database binary patching, what is actually left for the basis admin to do? We aren't out of a job, so where exactly does our configuration focus go when, say, a major database patch is released?
It's a great question. The answer is that our focus shifts from manual software installation to workload orchestration and timing.
Walk us through that.
Let's break down that patching scenario I mentioned at the very beginning of the deep dive. Let's say you've deployed a custom Node.js application. You route that application through the Cloud Foundry environment pillar you just mentioned.
Correct.
But beneath that application, the SAP HANA database is running as a containerized pod managed by Kubernetes.
A pod being the smallest deployable computing unit in Kubernetes, right? Basically a wrapper around the HANA database container.
Exactly. Now, SAP releases a new revision of the HANA binary. In the on-premise world, this would require you to log into the SAP support portal, manually download a multi-gigabyte SAR file, unpack it on the Linux file system, and run the HDBLCM command line tool.
The HANA Database Lifecycle Manager.
Right, to execute an in-place upgrade, just hoping nothing breaks.
But in HANA Cloud.
In HANA Cloud, you don't touch the binary. SAP makes the new container image available in their backend registry. Your job is simply to schedule a maintenance window and trigger a stop-and-start sequence for your database instance.
Walk us through exactly what the Kubernetes control plane is doing during that stop-and-start sequence. I mean, why is it so much faster?
When you issue the stop command, the Kubernetes control plane gracefully shuts down the HANA processes and spins down the pod running the older database binary.
Okay, but what happens to the data?
Crucially, your data isn't in that pod. Your data is sitting on a persistent volume claim, a decoupled storage layer. So when you issue the start command, Kubernetes spins up a brand new pod containing the patched database image and simply reattaches it to your existing persistent volume claim.
So the database starts up, reads the attached volume, and you're online.
Exactly.
Yeah.
You control the timing of the restart to minimize business disruption. SAP controls the container image availability and the orchestration logic.
That separation of compute, the pod, and storage, the persistent volume, is the magic of containerized resilience.
It really is.
It's why hardware failures are no longer catastrophic events. If the underlying physical server catches fire, Kubernetes just spins up your pod on a different physical node and reattaches the storage. It's a beautiful architecture.
However,
Right, there's always a however.
before you can actually touch a Kubernetes-backed HANA instance or start spinning up containers, you have to understand the strict landscape rules governing access.
Yes. You cannot simply log into a hyperscaler and start provisioning instances without navigating the BTP Cockpit entitlements.
Governance is where the rubber meets the road here. I mean, if anyone could just spin up a 128 gigabyte in-memory database container on a whim, your enterprise compute credits would evaporate by Tuesday.
Completely. So this brings us to the fundamental governance differences between an enterprise account and a trial account and how you establish your entry point.
The entry point for all landscape administration, your command center, is the SAP BTP Cockpit.
And as an engineer, you must memorize the exact access paths to this cockpit because they change depending on your architecture, right?
They absolutely do. If you are operating within an enterprise account, the URL you hit depends entirely on the regional deployment of your control plane.
SAP routes traffic based on data sovereignty and latency.
Right. So, for example, you will navigate to emia.cockpit.btp.cloud.sap for European deployments.
EMEA standing for Europe, Middle East, and Africa.
Exactly. You will use a mirror.cockpit.ktp.cloud.sap for the Americas and apac.cockpit.btp.cloud.sap for Asia Pacific.
Okay, but what if you are working in a highly regulated industry, like, say, European public sector or defense, and you require restricted EU access, where only EU citizens working within EU borders can even touch the infrastructure?
Then the path changes again. You must navigate to u-access.cockpit.btp.cloud.sap.
That's a crucial distinction.
Now, contrast all of that with a trial environment. If you were just studying, building sandboxes, and operating a free trial environment, the path has nothing to do with those regional enterprise URLs.
What is it then?
The path is explicitly account.hanatrial.ondemand.com/trial #home trial.
From an architectural standpoint, mixing these environments causes immediate hard-stop governance failures. I see junior architects make this mistake constantly. You have to design your proof-of-concept landscapes carefully to avoid entitlement conflicts.
It's probably one of the most common troubleshooting scenarios we see on the basis side.
What happens?
Well, a developer is logged into a massive enterprise SAP BTP account, and they want to test some new SQL logic without using up the company's paid capacity units. So, inside the enterprise account, they attempt to create a trial SAP HANA database instance.
Yeah.
The provisioning will fail instantly. It will throw a hard error. Trial instances simply cannot exist within the enterprise governance model. The control plane will block it at the entitlement check phase.
So how do you solve that? How do you give a developer a no-cost sandbox within an enterprise environment without breaking governance?
You have to utilize a specific entitlement. To provision a no-cost sandbox within an enterprise account, you must explicitly configure your sub-account entitlements to allow the free tier model service plan.
Okay, free tier, not trial.
Exactly. When you go through the creation wizard, you select free tier. It uses the exact same infrastructure as the paid tiers, meaning you can easily upgrade it to a paid tier later with zero migration effort.
But it limits your compute resources so you aren't charged.
Right.
And what if you don't have an enterprise account at all? Like if you're an independent consultant or a student forced to use the actual trial environment via that ondemand.com URL?
Then you must architect your sandbox tests around severe, inflexible compute limitations.
And these are not soft quotas where SAP politely emails you to upgrade, right?
No, these are hard Kubernetes container limits enforced at the hypervisor level by the BTP control plane. You must know these exact parameters for sandbox execution because they dictate what you can and cannot test.
Give us the numbers.
A trial SAP HANA Cloud instance is hard capped at exactly 16 gigabytes of RAM, 1 virtual CPU, and 80 gigabytes of disk storage.
16 gigs of RAM is barely anything for an in-memory engine.
It really isn't. And let's say you want to test federated queries, so you choose to deploy the integrated data lake component alongside the database.
Okay, what are the limits there?
That data lake instance is capped at 32 gigabytes of RAM, 4 virtual CPUs, and 256 gigabytes of storage. And you cannot scale these parameters up. There is no slider in the UI to give yourself 32 gigs of HANA RAM.
If we pause and analyze those hard limits, it actually reveals a massive aha moment about the strategic intent behind SAP's architecture. Why are the compute nodes separated like this? Why are they restricting the in-memory engine to a measly 16 gigabytes, but happily handing over 32 gigabytes and 4 vCPUs for the data lake? This perfectly illustrates the fundamental premise of SAP HANA Cloud data tiering.
Right, it's about the cost of real estate.
Exactly. The in-memory SHP database is designed for high-performance, volatile, hot data execution. It is loading data entirely into RAM in a columnar format to execute complex analytical queries in milliseconds.
But RAM is incredibly expensive real estate.
You do not want to store 10 years of archive sales orders in RAM. It's a complete waste of money. The data lake, on the other hand, is powered by SAP IQ technology.
And that's a disk-based relational engine, right?
Yes, designed for petabyte-scale cold or warm data storage. It uses extreme data compression and multiplexing to store massive volumes of data cheaply on disk.
So by giving you 16 gigs of hot storage and 256 gigs of cold storage in the trial, SAP is physically forcing you to practice data tiering.
Exactly. By separating these compute nodes, you optimize your tiered storage costs. You architect your data models to keep only the most critical, frequently accessed data, like the current fiscal year's live transactions in the expensive in-memory layer.
And then you push the historical or massive analytical data sets down to the cheaper data lake layer.
Right. And the beauty is, through SAP Age's virtualized access, your end-user reporting tool just queries the Age database, and the engine seamlessly fetches the cold data from the data lake without the user ever knowing it was stored on disk.
But you have to be really careful with those trial instances because SAP aggressively manages those hypervisor resources.
What do you mean?
If you deploy a trial database and a data lake, both of those systems will forcefully auto-stop every single day around midnight server time.
Every day.
Every single day. SAP reclaims the compute capacity. You will have to log in and manually restart them the next day.
Wow.
Furthermore, if your entire trial account remains inactive for 30 consecutive days, the BTP control plane will automatically suspend it.
And if you just leave it suspended?
After 90 days of inactivity, the account and all associated container volumes, including your persistent volume claims, are permanently deleted. There's no recovery.
Which makes sense. I mean, they aren't going to pay AWS or Azure to host your abandoned sandbox forever.
Right.
Okay, so let's move forward. Let's assume you have successfully navigated the BTP Cockpit entitlements, you understand your regional URLs, you accept the governance limitations, and you've successfully provisioned a HANA instance.
You have a running database.
You now require the correct tooling to actually monitor, configure, and administer that tiered environment. And here is a crucial point for architects. Navigating the basic BTP Cockpit cards is totally insufficient for database-level execution.
Absolutely. The BTP Cockpit manages the platform. It doesn't manage the database engine itself.
Right. This leads us directly to the deployment of the SAP Cloud Administrator's tooling trifecta.
This is where we really get into the daily workflow of the basis engineer.
Historically, we did everything in SAP HANA Studio.
HANA Studio.
It was a massive, heavy, Java-based Eclipse client that you had to install locally on your laptop. You used it for everything from provisioning to writing SQL to monitoring CPU spikes.
And managing those local client updates was a nightmare.
Exactly. But the administrative architecture of SAP Agent Cloud represents a complete decoupling of duties. SAP has deprecated that fat client and abstracted administration into 3 distinct web-based graphical tools: SAP HANA Cloud Central, SAP HANA Cockpit, and SAP HANA Database Explorer.
Each tool serves a specific, isolated architectural layer.
Wait, hold on. You're telling me I have to use 3 separate web tools just to manage one landscape?
Yep.
That sounds like a massive step backward for automation and usability. I mean, if I just want to check a crash dump and restart a service, why do I have to bounce between 3 different browser tabs?
I completely agree. It sounds counterintuitive at first.
As an architect who values streamlined pipelines, I hate GUI sprawl.
But you have to view this through the lens of microservices and security isolation. By decoupling these tools, SAP can update the Database Explorer without touching the underlying monitoring framework of the cockpit.
Okay, so they can deploy patches to the tools independently.
Exactly. Furthermore, it allows for granular security segregation. You might want a junior developer to access the Database Explorer to query their specific schema, but you absolutely do not want them having access to HANA Cloud Central, where they could accidentally delete the entire database instance.
Ah, okay. It separates the platform layer, the engine layer, and the data layer.
Precisely. Separation of duties is critical. So let's break down how you actually execute against these tools in the real world, starting with the highest level, the platform layer.
This is SAP HANA Cloud Central.
Right. Central operates at the landscape or instance level. But here's the catch. To activate Central, you don't just log into BTP and click a button. You have to explicitly provide your BTP sub-account the correct subscription entitlement.
Walk us through that exact configuration path.
First, you navigate into your specific BTP sub-account. You expand the left-hand navigation panel and you select Instances and Subscriptions.
Got it.
Then you click the Create button in the top right. This launches a creation wizard. In the service search bar, you must search for the service explicitly named SAP HANA Cloud.
Not just HANA, but SAP HANA Cloud.
Exactly. Once selected, you'll see a drop-down menu labeled Plan. You must select the subscription plan named Tools. You accept the terms and execute the creation. This binds the central application to your sub-account.
But provisioning the application subscription doesn't actually grant you access to use it, right?
No, it doesn't.
Because enterprise governance dictates that authorization must be explicitly mapped to your specific identity provider token.
Correct. And this leads to a mandatory troubleshooting step because everyone gets this wrong on their first try.
What happens?
Well, when you configure SAP HANA Cloud Central, you must navigate back to your BTP security settings, go to Users, select your specific user profile, and manually assign a role collection.
What's the technical name of the role collection?
The exact string you must add is SAP HANA Cloud Administrator. But here is the trap. If you just add that role collection and immediately try to open the central application link, the BTP control plane will throw an HTTP 401 unauthorized error right in your face.
Wait, why does it throw a 401 if you just gave yourself the admin role?
Because your active session token hasn't been updated with the new permissions.
Your browser is still passing an old JSON Web Token, or JWT, to the application router.
Exactly. The authorization scope array inside the payload of your current JWT doesn't have the new role yet.
So how do you refresh the token?
You must explicitly log out of the SAP BTP Cockpit entirely, closing the session, and log back in to force a fresh authentication against your identity provider.
And only then will the new JWT generate with the SAP Cloud Administrator scope embedded in it, allowing you past the application router.
You got it. Once you're finally inside Central, you use it for high-level macro operations.
Like what?
This is where you deploy new database instances, where you add a data lake to an existing AJ instance, where you trigger a backup recovery, or where you scale compute resources up or down by allocating more memory to the Kubernetes pod.
Okay, so Central is for managing the container and the landscape topology. But if we need to manage the actual in-memory engine running inside that container, we have to drop down a layer to the second tool.
Right, the SAP HANA Cockpit.
How do you get there?
To access the SAP HANA Cockpit, you don't need a separate subscription.
Yep.
You locate your running database instance inside SAP HANA Cloud Central, and under the Actions column, you click the More button, which is represented by 3 horizontal dots.
Yeah.
From that context menu, you select Open in SAP HANA Cockpit. It passes your authentication via single sign-on and opens the cockpit in a new browser tab. I call this the engine room.
What exactly are we executing in the engine room?
This is where you are operating natively at the database level. You are looking at the health of the engine.
Performance monitoring.
Exactly. You will execute tasks like monitoring memory consumption, specifically investigating if your column store tables are consuming too much RAM and pushing critical data out of memory.
And CPU utilization.
Yes, you monitor CPU resource bottlenecks here. You also configure alert rules. So, for example, if a disk volume hits 90% capacity, it triggers an email to the basis team.
What about users? Platform users versus DB users.
Right. You manage database-level users here, not BTP platform users, but actual DB users, and assign their granular system privileges. But most importantly, this is where you analyze SQL workload.
That is a critical point. Let's expand on SQL workload analysis. If a developer complains that a report is timing out, how are you using the cockpit to solve it?
You navigate to the performance monitor in the cockpit and pull up the SQL plan cache.
Okay.
You isolate the specific SQL statement the developer is running. The cockpit allows you to visualize the execution plan. It breaks down exactly how the database engine parsed the query, which indexes it used, how it joined the tables, and where the bottleneck is.
So you could see if a query is doing something inefficient.
Oh, absolutely. You might find that the query is doing a massive cross-join that's spawning thousands of parallel threads and completely starving the CPU. You can see all of that graphically in the cockpit.
Excellent. And that leads us to the final tool in the trifecta, where we move past the database administration layer and down into the actual data schema and development layer.
The third tool is the SAP HANA Database Explorer.
Accessed the same way.
Yes, just like the cockpit, you access it via the More button context menu next to your instance in HANA Cloud Central.
And what's the execution use case here?
It is strictly data and catalog manipulation. You use the Database Explorer to examine schemas, import or export catalog objects, and execute ad hoc SQL statements directly against the database via the SQL console.
You also use it to query HDI containers. Let's briefly ground that jargon because HDI is central to modern SAP development.
Right. HDI stands for HANA Deployment Infrastructure.
In the old days, developers just created tables in a massive shared public schema.
It was completely chaotic.
One developer could drop a table and break another developer's app.
Oh, it happened all the time. HDI solves this by creating isolated, containerized schemas at the database level. Each application gets its own private HDI container with its own private database user.
So the Database Explorer allows you to connect to and peer inside those isolated HDI containers to verify table structures or view data.
Yes, exactly. But the Database Explorer is also critical for deep diagnostic troubleshooting.
Give me an example.
Let's say your instance crashes, it hits an out-of-memory condition, and the Kubernetes control plane has to forcefully restart the pod.
Okay, an O event.
When that happens, the index server will generate a crash dump file.
Can you see that in the cockpit?
No, you cannot view that crash dump from the BTP cockpit.
Yeah.
You must open the SAP HANA Database Explorer, navigate to the Diagnostic Files folder, locate the index server trace file, and literally read the raw hex output to figure out exactly which query spiked the memory allocation and killed the engine.
Okay, I'm going to stop you right there.
Uh-oh.
No, I understand the separation of duties.
Yeah.
Central for the platform, Cockpit for the engine, Explorer for the data. But let me challenge this entire execution model.
Okay, go for it.
These web-based graphical tools are excellent for one-off tasks, visual health checks, isolated troubleshooting on a single instance. But as an enterprise architect, I don't build single instances.
Right, you build pipelines.
Exactly. I design CI/CD, continuous integration, and continuous deployment pipelines. If I am tasked with managing, updating, and scaling a fleet of hundreds of multi-cloud SAP HANA instances across different regions globally, clicking through cockpit cards simply does not scale.
Not at all.
Manual GUI interaction is an absolute anti-pattern for enterprise automation. It's prone to human error, it's slow, and it's not auditable. How do we programmatically execute against this infrastructure?
You are absolutely correct, and I'm glad you pushed back on that. GUI tools fail completely at CI/CD scale.
Right.
If I tell my basis team to manually provision 50 instances by clicking through Central, half of them will be misconfigured.
Without a doubt.
To script deployments, to automate memory scaling based on metrics, and to integrate your HANA landscape with pipeline tools like Jenkins or Terraform, you must bypass the GUI entirely. You must execute directly against the BTP API.
And this transitions us to the absolute required programmatic interface for SAP HANA Cloud.
Yes, the Cloud Foundry command line interface, or the CFCLI.
The CFCLI is the architectural bridge between your local automation scripts and those Kubernetes-backed SAP HANA Cloud containers running on the hyperscaler backend.
It's not just a nice-to-have.
Exactly. It is not an optional tool for advanced users. It is a mandatory foundational requirement for enterprise-scale administration. If you want to move toward infrastructure as code, you must master the CFCLI.
Let's get incredibly practical here. I'm going to walk you through the bare metal Linux installation and execution sequence for the CFCLI, specifically citing the exact syntax for a Debian or Ubuntu Linux distribution.
So you must execute these commands as a super user, right?
Yes. Step 1. Before you even install the binary, you cannot just blindly pull packages off the internet. You must download and inject the Cloud Foundry Foundation's public key to verify package integrity.
Right. This is a mandatory security handshake. Security at the package manager level is critical before pulling external CLI binaries into an enterprise environment.
Because if you don't verify the GKI key, you could be downloading a compromised CLI that intercepts your BTP admin credentials.
Exactly. So how do we do it?
Open your terminal and execute this exact string. wget at -q-o https://packages.cloudfoundry.org. wyankley.cloudfoundry.org.key sudo apt key add.
Let me break down the logic of that command so you aren't just memorizing syntax.
Go for it.
The w command fetches the key file from the server. The -q flag stands for quiet, which silences the standard output so your script doesn't get clogged with download progress bars.
Important for clean automation logs.
All right. The -o flag tells the system to output the downloaded file directly to standard output rather than saving it to a file. We then use the pipe symbol to take that output and feed it directly into the standard input of the sudo apt key add command, which registers the key in your local trusted key store.
That is a beautiful breakdown of the mechanics.
Once the key is trusted, what is step 2?
Step 2, you add the trusted repository to your package manager sources. You execute echo deb https://packages.cloudfoundry.org debian stable main sudo t at capsources.list.d cloudfoundry-cli.list.
So this tells your Linux system exactly where to look when you ask it to install or update the Cloud Foundry tools.
Exactly. Finally, step 3, you update your package cache and install the tool. Execute sudo apt-get update, followed immediately by sudo apt-get install cf8 CLI.
Notice that you specified CFH CLI.
Yes, you must ensure you specify cf8 CLI to pull the version 8 binaries. Version 7 is deprecated and will fail when attempting certain modern BTP API calls.
Okay, so with the binary successfully installed on your local machine, the next architectural requirement is establishing an authenticated session with the correct BTP region. The CLI needs to know which API endpoint to target.
And this maps back directly to what we discussed earlier regarding regional routing URLs for the BTP cockpit. The API endpoints follow the exact same regional logic.
Precisely. To establish the session, you execute the login sequence.
The command is cf-login-ci, followed by your specific API endpoint URL.
What does the AFEF do?
The A flag specifies the API target. You are telling CLI exactly which regional cloud controller to talk to. For example, if you are operating in the European trial region, you would execute cf login-https.api.cf.eu10.hana.ondemand.com.
And once you hit enter on that, how does authentication work? Does it pop up in a browser window?
In a standard terminal execution, it will prompt you inline. The terminal will ask for your SAP ID email and then your password.
What if your enterprise uses multi-factor authentication?
If your enterprise uses MFA with a custom identity provider, the CLI supports SSO pass-through flags, but for a standard login, it's just email and password. Once authenticated, the CLI will prompt you to select your target organization and space.
Let's define space quickly. On Cloud Foundry architecture, an organization is typically a business unit like finance or HR.
Right.
A space is an environment within that org like development, QA, or production. When you deploy a A-to-E database, it is always bound to a specific space.
Exactly. Once you are authenticated and targeted to a space, you can begin exploratory execution. You can verify your client version with CF version.
Or look up commands.
Right. You can list all available commands with CF help, or look up the specific syntax and flags for a command by typing CF help followed by the command name, like CF help services.
Let us focus deeply on that services command. Architecturally, this requires a mental shift.
It really does.
When you deploy an SAP key in a cloud database, Cloud Foundry doesn't view it as a database server. It abstracts it completely. Cloud Foundry views it simply as a service instance that has been provisioned and bound to a space.
Exactly. Whether it's a HATINA database, a data lake, or a message queue to the CF-CLI, it's just a service. To see every running database or data lake in your current targeted space, you simply execute CF services.
What does that output look like?
This will output a formatted table of all instances, showing their names, their current status like create succeeded or update in progress, and any applications that are currently bound to them.
And if I need granular detail on a single database?
You drop the is. If you need the exact connection strings, the full status message, and the specific plan details for a database, let's say you named your instance HC200 trial database. You execute CF service HC200 trial database. That gives you the deep dive output for that specific instance.
But here is the most critical concrete scenario we have to discuss.
The provisioning failure.
Yes, this is where architects and engineers constantly fail during their first attempt at automated provisioning. If you are writing a bash script, or you are configuring a Terraform provider execution to deploy a brand new SAP HA Cloud instance, you cannot just tell the API, build me a HAP database.
No, the API has no idea what that means.
You must pass the exact technical name of the service plan to the API during the creation call.
This is a major stumbling block. You cannot guess the service plan name. It is not just HANA. Before you write your deployment script, you must query the BTP service marketplace directly from your CLI. You execute the command CF marketplace. This command queries the API and returns a comprehensive list of all entitled service offerings and their associated service plans that are currently bound to your specific BTP account.
To analyze why this step is absolutely mandatory, you must understand how the Cloud Foundry CLI interacts with underlying service brokers.
Right.
Think of the BTP marketplace as a digital catalog. A service plan is simply an advertised database configuration profile within that catalog.
It's defined by the Open Service Broker API standard.
Exactly. The Open Service Broker API standard dictates that the CLI must query the catalog, retrieve the advertised plan, and instruct a broker to provision infrastructure matching that exact plan profile. You are essentially ordering from a programmatic menu.
Precisely. If you run CF Marketplace and you see a service offering called HANA and a service plan called free, you must extract that exact technical string. You use that string as the parameter in your automated creation script. For example, CF create service HANA free my new database.
And what's happening on the back end when you run that?
The CLI commands abstract the incredibly complex Kubernetes deployments happening on the back end. When you send that create service command, the CF Cloud controller talks to the HANA service broker.
The broker talks to the Kubernetes control plane.
The control plane provisions the persistent volume, spins up the pod, mounts the volume, and returns a success signal back to your terminal. By mastering CF Services, CF Service, and CF Marketplace, you control that entire lifecycle directly from your local terminal.
We have covered immense technical ground today. This has been a dense, rigorous exploration of the architecture and execution mechanics.
It's a lot to take in.
To synthesize this journey, we began by mapping the in-memory HTAP paradigm to the Kubernetes-backed BTP multi-cloud structure. We explored why the abstraction of the hardware fundamentally shifts your responsibilities.
Away from patching and towards orchestration.
Exactly. We defined the strict compute limitations, the regional routing URLs, and the governance pitfalls of the BTP Cockpit. We mapped the administrative decoupling across SAP HANA Cloud Central for platform instances, the Cockpit for in-memory engine monitoring, and the Database Explorer for HDI container and schema manipulation.
And we scaled our administrative capabilities by recognizing that GUI tools fail at CI/CD scale.
Moving instead to establish bare metal programmatic control via the Cloud Foundry CLI.
My final call to action for you is to apply these execution mechanics immediately. Do not just listen to this deep dive and think you understand it.
You have to get your hands dirty.
Boot up a Linux terminal or a WSL environment on your laptop. Execute the JICAR and apt-get installation sequences exactly as I described them. Establish your CF login against a trial environment. Run a CF Marketplace query against your BTP account and analyze the output.
You must develop muscle memory for these CLI commands and BTP subscription paths in a sandbox environment before you ever attempt to touch an enterprise production system.
Completely agree.
And I will leave you with a final, forward-looking architectural consideration pulled directly from the course syllabus. We spent this deep dive mastering the exact syntax of the CF CLI, analyzing execution plans, and navigating manual cockpit cards. But looking at the evolution of the SAP architecture, we are on the precipice of another massive shift.
What?
SAP is currently integrating Joule, their generative AI assistant, directly into SAP HANA Cloud Central and the BTP Cockpit. I want you to consider how your role, your CI/CD pipelines, and your daily execution mechanics will fundamentally change when you no longer need to type SAMneo services into a terminal or manually parse a hex trace in a crash dump, but instead simply ask Joule to analyze your SQL workload, identify the bottleneck, and independently scale your Kubernetes compute nodes to resolve it.
That is going to rewrite the rules all over again.
The architecture is evolving, and you must evolve with it.